In the last lecture, we were discussing about different types of stresses. For example, if this is a stress element, if this is a stress element, then this is the normal stress that is acting on this particular element. And this is the normal stress in y direction, and also at the same time we have the shear stresses that are acting on this particular and also this one. Now, as I told you in the last class that these stresses are acting on a straight cross section of the element, but actually the maximum stresses or the maximum shear or normal stresses are not maximum on this or does not exist on this straight element. In fact, those maximum stresses are at some inclination to this straight axis or to these perpendicular stresses. For example, this is the straight element, but, but it is quite possible that the normal stresses or the maximum normal stress is at this plane, this inclined plane at any angle theta. So for example, if I say that this is an and if this black one is the straight element and this red one, if I draw it again, this red one is the inclined element, then the stresses on this red element would be again, let's call this as sigma, and the stress that is acting parallel to the face would be again shear stress, or let me call this over here. Now these stresses that are on inclined element cannot be determined directly. For example, for the straight stresses we have direct formulation for sigma, that is my over I, and for tau that is again vq over ib. But for this inclined element or for this inclined stresses, we need to develop some formulation. In fact, we have the straight stresses or the stresses on the straight element sigma x, sigma y, and tau x, y, etc. So we need to develop some formulation to convert these stresses on the straight element to the stresses on these inclined element, and these formulation are just uh, can just be developed by solving the equation of equilibrium, that is sigma fx and sigma fy. These are not so complicated, but this is one of the most important topic of this course, to figure out the stresses on the inclined element if you are provided with the stresses on the straight element and vice versa. So if I draw this small triangle, this one again over here, then that would be, and I suggest you to keep making notes with me, because some things are very complicated and you can understand only if you have your own notes. So if this is the angle theta, this one, and on the straight face we have sigma x, over here we have tau xy, and on the inclined face we have the normal stress as sigma, and this one is tau, right? And again on the bottom face we have tau yx, and this stress is sigma y. So these are all the stresses that are acting on this particular triangle which I have shown over here. Now I will apply the resolution of forces and figure out we will develop some formulation for these two inclined stresses sigma and tau that are acting on a plane which is at angle theta with respect to the straight plane, right? So again, these are the forces or these are the stresses that are acting on the element. Now if I want to represent the force, can you tell me what is how can I represent these stresses in terms of force on this inclined element? You know this formula that stress is equal to force over area. If I want to represent these stresses with respect to the force, then what will be that? I need to multiply this stress with the area on which this stress is acting. For example, this is a wedge shape. I am showing you the front side of this one. This wedge shape is also going, if I show exactly, it will be going inside the paper, something like this one, right? And these stresses are basically acting normal to this particular area which I have shown over here. Now this area is actually going inside the paper, and same there will be area below this one and behind this one, that is the area on which these particular stresses are acting. Now if I multiply these stresses with the area of, or with this inclined area which I have shown with this dotted line, then I will directly get the force. Let's suppose that the area of this wedge is equal to A, right? So this is sigma, and if I multiply this A with sigma, I will get the force. Now this figure was for the stresses and this figure is of the forces. And in the same way, the shear stress which is parallel to this inclined phase would be A into tau. And the stress that is acting on the, now if this particular area is A, this angle is theta. Let's say if this area is A, this angle is theta, what will be this area? Can I call that this area would be a sine of theta? Because this angle is theta, this area is A. Let's suppose that this length is A, this angle is theta. What would be this length? That will be again, the side in front of theta would be again A sine theta by using the perpendicular triangle rule. And again, this one would be A cos theta. Now we have three areas. This one is we assumed as A, and this one in front of theta would be A sine theta, and alongside the theta would be A cos theta. Now we have the area, and the stress that was acting on this phase was sigma y and tau xy, tau yx. If I want to convert this into force, that would be sigma y sine of theta, and this one would be tau yx A sine of theta, and over here is also A. Now these two have been converted into force, and on the same page, if I want to convert this into area, that would be sigma x A cos of theta and tau xy A sine of A cos of theta. Now we have converted all the stresses into forces. If I draw these forces on two axes, that would be one force is this A sigma, so I can represent it over here, that is A sigma. Let's call this axis as N axis or axis of normal stress, and the other force is A tau, that is this force. Let's call this as axis as T axis, and the force that is acting in downward direction is this one, that is sigma y A sine of theta, and the force that is acting in positive x direction is this one, that is tau yx A sine of theta, and in the negative x direction we have another force, that is sigma x a of cos theta, and in the upward direction we have this force that is tau xy a cos of theta. This angle is theta. If this angle is theta, then this angle would also be theta, and this angle would be theta, and this angle would also be theta. So now we have represented all the forces that are acting on this wedge element on these two axes, or on this n and d axis. Now, is there any confusion about this one? If you have any question, you can ask me now, because this is very important and the whole derivation is based on these four diagrams. If you have any question about these four, you can ask me now. So I assume that you have understood this one. So if I resolve now, what is our main aim in this derivation? We have to represent these stresses, or these inclined normal and shear stresses, in terms of these straight normal, or in terms of these normal and shear stresses that are acting on the straight plane. So we will do the resolution of forces. For example, if I write the equation of sigma Fn, or the or for this normal stress, or for this normal axis which is at inclined to the straight axis, what will be my equation? My first stress would be again this A sigma, and that is acting on the positive n-axis. And what other stresses are acting on this n-axis? I have to convert all these stresses, or transform all these stresses on this n-axis. For example, first let's start with this sigma x a cos theta. If I transform this on this n-axis, that would be this stress, right? And what will be this stress? Alian, can you tell me what is this particular component of sigma x a cos theta?
So ये हो जाएगा एक सेकंड सर ये हो जाएगा सर इसको हाइपोटेन्यूज सर ये हो जाएगा सिग्मा एक्स ए कॉस थीटा ओवर थीटा
A cos theta
over theta
over theta. Varun,
over cos theta sorry sir
eh?
over cos theta होगा
Why over cos theta? For example, if you have the force, let's say if you have this force 12, and if you want to find out, if this force is 12, if you want to find out this component, this one, what will be that component?
cos थीटा ओवर हो जाएगा सर खाली
12 cos theta, right?
yes sir
So this is the same thing. I have this component sigma x a cos theta. I want to find out this component. What would be that? Sigma x a cos theta into cos theta.
मैं शायद कैलकुलेशन दौरान मैं शायद वहाँ गलत कर दिया सर सॉरी
So चलो इस फोर्स का n कंपोनेंट बताओ. Sigma y a sin theta. This one.
सर इस फोर्स का कौन से वाला
N component. Yeah, let me show it over here. This component.
सर सिग्मा वाई ए साइन थीटा
Sigma
Into-
y into
सर साइन थीटा हो जाएगा.
Yes. So इसी तरह we will write the components of all these forces. Let's write the one for T by X. Very simple. This one, what will be this component? Let me this would be sine component and
साइन स्क्वायर हो जाएगा.
eh? No, we need to find out the n component for this force. This one. Let me show it over here. This is n axis, this is t axis, and this is tau yx is sin theta. हमें ये component इसका चाहिए. So what will be this component? This component of this tau yx is sin theta, because we are writing the equation for n axis. So what will be this component? Can I say that it would be minus tau yx a sine of theta, and this is obviously the cos component. This one would be sine component and this one would be cos component, right? So any confusion about this one? Abdullah, समझ आ गई है?
नो सर.
हैं?
सर हम ये जो ड्रॉ कर रहे हैं ये एक तरह से नेगेटिव ए सिग्मा नहीं बन जाता?
हैं? नेगेटिव?
सर ये जो हमने कॉस थीटा इसको ड्रॉ किया है अभी,
यस.
ये अगर हम अपने ऊपर रेड वाली डायग्राम में देखें तो ये नेगेटिव ए सिग्मा नहीं बन जाता?
तो ये नेगेटिव साइन इसीलिए मैंने लगाया है. इधर पॉजिटिव साइन. ये ऑपोजिट
पूरी टर्म कौन सी है?
है.
tau by x is sin theta into cos theta.
ये वाला जो कंपोनेंट है, ये जो स्ट्रेट एक्सिस है, दैट इज tau yx a sin of theta, राइट?
ठीक सर.
हमें ये इंक्लाइन कंपोनेंट चाहिए. एंगल हमें पता है थीटा है, तो इंक्लाइन कंपोनेंट क्या होगा? थीटा के जो थीटा के सामने वाली साइड अगेन साइन थीटा होती है, दूसरी साइड वुड बी cos थीटा. तो दैट हमें we will simply multiply it with this one.
Okay sir.
And the last force is this tau xy. So what will be the n component? I can show it over here. That would be this one. So what will be this component? This one.
Sir, tau by a cos theta sin theta.
Again it is in negative direction, so that will be tau xy is cos theta, because we have cos theta over here. A cos theta and sin theta, right? So now we have resolved all the forces 1, 2, 3 and 4 in on their n axis, and also we have represented this a sigma force on this n axis. So this is the equation for the sigma Fn. Now on the same grounds we will write the equation for sigma Ft. So on t axis, how many forces? Again 5 forces. One force is this a tau. So we will say that a tau would be equal to, and just keep one thing in mind, that we are taking this direction of n axis as positive, and for tau axis we are taking this downward direction as positive, right? So just keep this thing in mind, and we will take this as reference in our questions as well. So now we have to transform these four forces on the t-axis. So first, let's begin with sigma x again. The component on tau axis would be this one. So what will be this one? Monim. क्या होगा ये component?
मुनीम सर मीटिंग में नहीं है, आप कहते हैं मैं उसको उठा देता हूँ।
तो पहले तो मीटिंग में था, चलो तुम बताओ ना ये कंपोनेंट क्या होगा।
सर ये हो जाएगा सिग्मा एक्स ए कॉस थीटा साइन थीटा।
So that would be sigma x a cos theta into sin theta, right? And then we have the component for sigma y, which would be this, but I will show it over here. Sigma y is sine of theta and this component, this angle is theta. So again, this component will be the cos component of this force. So I will have sigma y a sine of theta into cos theta. Now I'll be writing the equation and you can resolve these forces. If you feel any confusion, you can again ask me. Then the
साइन नेगेटिव क्यों आया?
which one?
सर सिग्मा वाई का साइन कंपोनेंट का, सॉरी कॉस कंपोनेंट का।
No,
Yes,
it is. It should be positive. Wait, let me see. This is sigma y. And it will be in this direction. If we resolve this force, do you think so? It will be in this upward direction, right? I've shown it over here as well. Over there you can see. What will be this sign?
Okay.
So that will be positive one. Sorry, that would be negative sign in this upper direction because we have assumed this sign as negative. So our component is in this upward direction. So that will be positive one. Okay.
सर हमने डाउनवर्ड तो पॉजिटिव लिया।
Sorry, downward is positive. This is upward, right? So upward is negative. So that's why there is a negative sign. This is just the resolution of forces by this triangle, by plotting the triangles. And so if I again, the other two forces will have tau xy, a cos of theta, and again the component would be cos theta, and the fourth force will be minus tau yx, a sine of theta into sine theta. Now the next step will be just to simplify these equations and get a formulation of this tau in terms of sigma x and tau xy. So we will start with equation 1. This one. This area would be cancelled out. So we will be left with sigma is equal to sigma x cos square theta plus sigma y sine square theta minus Now we also discussed that this tau xy and tau yx, all the shear stresses are same in magnitude, but only difference is the sign notation or direction. So these two will have same magnitude, so they will add up, and we will be left with tau, 2 times tau xy. Both of them has sine theta and cos theta term, so that will be sine theta and cos theta, right? Now, if you remember, there were some identities that we have studied, or you have studied in basic courses, that cos square theta would be equal to 1 plus cos 2 theta by 2, sine square theta is equal to 1 minus cos 2 theta over 2, and sine theta cos theta is equal to sine 2 theta by 2, right? So now we will replace these identities into this equation, and we will get sigma is equal to sigma x 1 plus this cos square theta would be 1 plus cos 2 theta by 2. Similarly, sigma y plus sigma y, this sine square theta would be equal to 1 minus cos 2 theta by 2, and this sine theta cos theta would be sine 2 theta by 2. So minus 2 tau xy sine 2 theta by 2. So this 2 will cancel out with this one. If I further simplify this one, I would get sigma x by 2 plus sigma x by 2 cos 2 theta plus sigma y by 2 minus sigma y by 2 cos of 2 theta minus tau xy sine of 2 theta. So if I take these two terms together, that would be sigma x plus sigma y by 2 plus sigma x, these two terms together, that would be sigma x minus sigma y by 2, cos 2 theta would be common, minus tau xy sine of 2 theta. Now, in this equation, you have represented the normal force that is acting on an inclined axis in terms of these straight sigma x and sigma y. Now, if you have a question where it is asked that this is a beam and you need to find out the normal stress at this particular point at an inclination of 30 degree, right? For example, if this is the question, now you can, what will you do? First, you will figure out the stresses on this particular straight plane, and for that you have direct formulation, that is sigma is equal to my over I, and for tau you know Vq over Ib. Once you have this sigma x, sigma y and tau xy, and you also know that this angle theta, you will simply substitute all the values into this equation, and you can get directly the forces at any particular angle theta. For example, angle 30, 45, or you can find out the forces. And also, we will see that how to get the maximum stresses. Anyway, now this is the formulation for the normal stress at an inclined angle theta. Now we have to derive the similar formulation for the shear stresses at an inclination. So for that, we will use the same equation, this equation. So this area would again cancel out, and we will be left with tau is equal to sigma x cos theta into sine theta minus sigma y sine theta cos theta plus tau xy cos theta cos square theta minus tau xy sine square theta, right? Now again, if I substitute those identities, I will get sigma x sine 2 theta by 2 minus sigma y sine 2 theta by 2 plus tau xy 1 plus cos 2 theta by 2 minus tau xy 1 minus cos 2 theta over 2. So if I simplify this one, what will I get? Tau equals to this sine 2 theta would, I can take this sine 2 theta as common. So that would be sigma x minus sigma y by 2 into sine 2 theta plus tau xy by 2 plus tau xy by 2 cos 2 theta minus tau xy by 2 and minus tau xy by 2. Sorry, that would be plus cos 2 theta. This will cancel out. So the final equation for tau will be sigma x minus sigma y by 2 sine of 2 theta plus these two will add up and we will be left with tau xy cos of 2 theta. Now this is the equation for the shear stress at an angle theta with respect to the normal stresses, right? So now, for example, if this is the straight element and these are sigma x, sigma y, and this is tau xy, right? So we have developed the formulation for, and this is the straight element, and this is the inclined element, and this is sigma n for which we have developed this particular formulation, and this is again tau, let's call this tau theta. Now we have the formulation, but also on this inclined axis, there is this particular stress that is acting at 90 degree to this inclined sigma n. So if this is sigma theta, for example, if this is the straight axis, this is acting at an angle theta. So if this is sigma theta, then there is another stress that is acting at this angle sigma theta plus 90 degree, right? So one way is that if we have been provided with this angle theta and we want to figure out this particular stress that is acting at 90 degree to this inclined one, this angle is 90 degree. So we can directly substitute the value theta is equal to theta plus 90 into this equation, and we will get this particular stress. One way is by doing this, and the other way is we can simplify this equation by substituting the value in this one. For example, the angle theta is 90. So if I want to figure out the formulation for that particular stress, that would be sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos of 2 into angle is 90 minus tau xy sine of 2 into theta plus 90. So again we know the identities that cos 2 into theta plus 90 is equal to minus cos square theta, sorry, minus cos 2 theta and sine 2 into theta plus 90 is equal to sine of 2 theta. If I substitute the values back into this equation, so that would be sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 So this is a negative sign. We will have negative sign over here now, and cos 2 theta plus, so that would be minus tau xy sine of 2 theta. Actually, there is a negative sign with this one as well. Both of these identities have the negative sign. So that will be plus tau xy sine 2 theta. You can also confirm this using your calculator.
सर थोड़ा सा ऊपर चल जाएंगे, जरा थोड़ा सा राइटिंग थोड़ा सा पीछे ला कर गया हूँ.
What?
could you व्हाइट बोर्ड को थोड़ा सा ऊपर कर देंगे प्लीज, एक सेकंड, थोड़ा ये जूम आउट कर दें.
I was writing this side.
हाँ,
I just substituted the value of theta as theta plus 19 with this equation.
बस ठीक हो गया. थैंक्स, मैं स्क्रीनशॉट ले लिया फिर.
सर आई गेस जो हमने बाद में किया ये नेगेटिव साइन टू थीटा नहीं आता, ये साइन टू थीटा ही आता है, क्योंकि a प्लस बी वाला फॉर्मूला होगा ना, साइन अल्फा कॉस बीटा प्लस कॉस अल्फा साइन थीटा.
Do you have the calculator? You can just substitute some values and confirm this one.
ओके सर, जस्ट
Let me try. Yeah, it is positive sign, so that will remain as negative. But I will confirm this one. There is some issue in this one. No, there is a negative sign. I have just confirmed from the calculator. You can just substitute some values into this equation. For example, that would be sine 2 theta plus 180, right? And on the other side, we have sine 2 theta. Let's say theta is equal to 30 degree. So what will be this angle?
साइन 240.
Sine 240. So what is sine 240? Minus 0.86, right? And
Yes, sir.
sine 60 is obviously 0.86. So there is a negative sign in this one. So we have this equation of sigma theta plus 90. Now you can figure out all the stresses that are acting on the inclined element. You have the formula for sigma theta, you have the formula for tau theta, and you can figure this out. So if there is any question about this, you can ask me now.
तो सर बेसिकली जो भी ट्रांसलेशन ऑफ इंक्लाइन स्ट्रेसेस वाला है क्वेश्चन होगा वो इन्हीं इक्वेशन से होगा.
Yes, transformation of straight stresses to the inclined plane.
ठीक सर.
So now I suggest you to do all this derivation again by yourself, and only then you can clearly get all the idea that what we are doing, particularly these four figures, these are very important. when you solve this whole, when you need to plot these figures again, understand what each term means, and then do this derivation again. Only then you can understand. It is just the resolution of forces, but once you do it by yourself, then you will have clear idea that what we are doing and how will we apply this in our numerical question. And again, if you feel any confusion, you can ask me. In the next class, we will do the principal planes and principal stresses and do a small derivation for that one also, and then we will move on to the numerical problem. So this is it from today's class, and if you feel any issues, you can again send me a message or we can discuss again.